Hi, welcome back to part 2 of Product and Quotient Rule. Welcome to the hardest problem ever. F of x, we want to take this derivative. This is a quotient rule, so it says x squared plus 2 over the fourth root of x. Now the first thing I'm going to do, I don't like that fourth root of x there, so I'm going to write this as x squared plus 2 over x to the 1/4. So now when I take the derivative, now one thing cool about calculus, you have an awesome calculus tutor online here. Calculus is easy. You're going to do calculus really well. The derivative is actually easy. It's just cleaning it up. I'm going to write this becomes x squared, when I take the derivative quotient rule, it said, remember, low times the derivative of the top, low, d high, remember our rule from earlier, right, for quotient rule, low, d high, minus high, d low, all over low, low. So, low, d high, minus high, d low, when I take the derivative of the bottom, be very careful, 1/4 x to the negative 3/4. I subtract 1. We're going to divide that by the bottom squared. And I'm just going to write this as x to the 2/4. Now, that's my derivative. Calculus done. Can I get a what? What? Yes, calculus is done. The rest is just algebra. Because here's the problem. We can't have negative exponents. No negative exponents. And what you're going to want to do is you're going to want to bring that down to the bottom. And you can't do that. It's not so simple. We have two quantities on top. It's not as simple. For me to bring this down just on the bottom directly, this would have to have an x to the negative 3/4 as well. So what I'm going to do, just a little bit of algebra, I'm going to write this as 2x to the 5/4. Very simple to do. That's just adding them, right? That's 4/4. Minus, and this becomes x squared plus 2. Watch how I'm going to write this. This goes on the bottom. So when I put just over under the x squared plus 2, 4x to the 3/4, and now this is all over my x to the 2/4. And you may be like, man, that just made it more complicated. Well, you're technically right because this is considered a complex fraction, which again, the rule, no complex fractions. See, my equal sign's not even in the right place. It should be down here. So what I'm going to do is I'm going to do an algebra rule trick here. I'm going to multiply both top and bottom by the LCD. And the LCD is only this 4x to the 3/4. 4x to the 3/4 here, 4x to the 3/4 there. And I'm going to distribute. Well, when I distribute this one, be careful, I can multiply the 4 and the 2, that gives me 8. I have x to the 3/4 times x to the 5/4. Well, that's just x to the 8/4, which is just x squared. Minus, when I distribute here, why we multiply by the LCD? Gets rid of that denominator. Minus is x squared plus 2. And on the bottom, I get 4x to the 5/4, because I'm just going to add their powers again. And there's your derivative right there. But I can simplify it, and we probably should. 8 minus x squared. Now notice I did put this in parentheses still because I got to distribute that negative. We get, from up here, I'm subtracting that. So I get, 8 minus the 1, I get 7x squared minus 2 over 4x to the 5/4. Watch this one again and 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 again. You want to know this one because two reasons. One, it's a hard derivative to take. Two, you got to learn the algebra for what we're going to be doing later on this year. Okay? So practice that one. All right. Now that we're done with that one, I just want to take a look a little bit more about some trig problems here. Okay? So a little bit more practice with the trig ones. Okay? So trigs. We know from earlier that the derivative of sine of x is cosine of x. And that the derivative of cosine of x is negative sine of x. You may recall from part 1 that the derivative of the tangent of x is the secant squared of x. Well, you can use the same process we did tangent to get the derivative of cotangent of x. And what you're going to find out, this is negative cosecant squared of x. Start to see a pattern? Yeah, there is. Now, the two other ones, what about secant of x? Well, that's just the derivative of secant is secant x tangent of x. And the derivative of cosecant of x is negative cosecant of x cotangent of x. And those are your derivatives for all the trigs. Now here's how I know the top three. This one I derived. This one I just memorized. This one I just memorized. Sorry about that. But these ones I just get from their counterparts. Cosine becomes sine, secant, cosecant, secant tangent, cosecant, cotangent. The only thing different is the cos go negative. Well, except for this one here. This is just a negative, negative, negative. Cos, co, negative. Very easy to do. Cosine becomes negative sine. Cotangent, negative cosecant. Cosecant, negative cosecant, cotangent. Cos, co, negative. And that can help me find any derivative. Like what if I had h of x equals 5 sine x plus 2 cosecant x minus the tangent of x. I have no idea what that function is, but I can derive it. Take the derivative, h prime of x, leave the 5 alone, 5 cosine of x plus 2 cosecant, negative cosecant x, cotangent of x, minus tangent, secant squared of x. And we're done. And the last thing I want to show you is just what we call analytic derivatives. Analytic derivatives. Let's say h of 2 equals 5, h prime of 2 equals negative 3, and I say g of 2 equals 1, and g prime of 2, the derivative at 2, equals, I don't know, give me a number, negative 4. I don't know, I'm just making that up. And I say let f of x equal h of x times g of x. We call these analytic derivatives. So if I want to find f prime of 2, so find f prime of 2. Well, the first thing we need, of course, is the derivative, so be very careful. You're going to want to do h prime of x, g prime of x. That's the natural instinct. But be careful. I'm multiplying, so which rule do we have to use? Product. So we get f of x equals f prime of x, the first, h of x times g prime of x, plus the second, g of x times the derivative of the first, h prime of x. And now everywhere there's an x, I plug in a 2. h of 2, g prime of 2, plus g of 2, h prime of 2. I just simplify that. h of 2 is negative 3 times h of 2 is 5, 5 times negative 4, g prime of 2, plus g of 2 is 1 times negative 3. And that just becomes negative 23. So the slope of f at 2 is negative 23. These are called analytic derivatives. We tend to see them quite often. Now the only other thing that you might see that you might have a little bit of trouble is what we call something that we call higher order derivatives. And that's easy to do. Let's say we have f of x equal 3x squared plus 4x minus 7. And I say find f double prime of x. Well, this f double prime just means I want the second derivative. Now in physics we call that acceleration. So I find the first derivative, easy peasy, 6x plus 4. My second derivative, I just do it again, 6. Now there's my answer. But if I keep going, I take the third derivative, I get 0. It's interesting, this is what we call a derivative annihilator. Annihilator, can't spell very well today. In other words, the derivative became 0. So, normally taking up derivatives, they can become 0. Now, the only thing that does not have a derivative annihilator is what if I did like a trig function? Let's say let's say y equals, let's just make up one here, 5 sine of x plus x squared. And I say find, now watch this one, d2y over dx2. The same thing, the 2 here just says I want that second derivative. So if I take the derivative, the first derivative dy dx, because they use dy dx, becomes 5 cosine of x plus 2x. Now, the placement of the 2's is very important. Years ago, I used to know why we placed them there, but I lost curiosity a long time ago. But if you're interested, I'm sure the book says it, or you can find them online. I probably should do that too myself. So when I take the second derivative, I get 5. This is negative sine of x plus 2. Now there's my derivative, which is just basically negative 5 sine of x plus 2. Don't forget to set that equal to the derivative itself. Show that it's the second derivative. But if I keep going, let's find the third derivative. This becomes negative 5 cosine of x plus 0. Now notice this gets annihilated. Gone. But cosine does not. It just repeats itself. Cosine and sine repeat themselves. They cannot be annihilated. So anyway, so that's the rest of the unit. Hope you guys enjoy it, and I'll see you guys later. Bye-bye.